see here. Okay, we're going to discuss in this session solving radical equations. Alright. Solving radical equations. Alrighty. Let's say we have 2x. Nothing for me to talk about up front. It's just one of those lessons where we just got to get down to doing the work. Alright, so here's our first example. Square root of 2x minus 5 equals 7. Alright, in order to get the x isolated, the first thing we got to do is get this information from under this radical sign. And we talked about, since this is a square root, to get rid of the square root, you square, because the square cancels the square root. If I square one side, then I have to square the other side. So now over here, square and square root are cancel, so it'll just leave me what was under the square root sign. And over here, 7 squared is 49. Alright, now I just solve it like a regular problem. So you have 2x equals, what is that, 54. Divide both sides by 2. X equals, what is this, 27. Alright, x equals 27. Now, here's the thing. Alright, this is where things are a little bit different. You always want to check your solution. You always want to check your solution when you're dealing with radical equations, in particular even root radical equations. Alright, so let's check. Alright, we're saying x is 27 in our initial problem, so we take our 27, plug it back into our initial problem. So we had square root of 2 times x, and x is now 27, minus 5, right, all under the radical, equals 7. Alright, so now we have to say, first of all, it was 2 times 27, it's 54. Then 54 minus 5 is 49. Alright, and it's under the radical sign. 49 is under the radical sign, and that's supposed to equal 7. And what does the square root of 49 equal? 7. 7 equals 7. Alright, so x equals 27 is the solution for this equation. Alright, and the book refers to it as writing it like that to say it is a solution. Alright, and this part here was just the check. Alright, but you have to do the check. Okay, you have to do the check to make sure everything works out at the end. Okay, so now let's look at another one. Let's say we have square root of 3a. Alright, 3a plus 4 equals a negative 4. Alright, square root of 3a plus 4, alright, equals a negative 4. Let's solve this one. Okay, we have the radical sign as a square root, so again, get rid of square root, square both sides. So now the square and square root will cancel and just leave you 3a plus 4, and over here negative 4 squared will give you a positive 16. So now minus 4 minus 4, 3a equals, what is that? This is a 4 too, oh, by the way. Make sure we're not confused. That's a 4. 16 minus 4 is a 12. 3, a equals 4. Okay, a equals 4. So that's what we found. A equals 4. So now we have to take it, plug it back into the initial problem. So now we do our check. Okay, so we start by saying square root 3 times 4 plus 4 equals negative 4. Third root, square root of 3 times 4 plus 4 equals negative 4. Okay, now 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 equals negative 4. Square root of 16, 4 equals negative 4. Alright? Alright, 4 doesn't equal negative 4. So 4 is not a solution, does not equal. X does not equal 4. Excuse me, wrote that wrong. X does not equal 4. We found the 4 here, but when we plugged it into our check to check it, we see that we got something that doesn't work because of what we see right here. Alright, so since the only answer we got over here is 4, and we check 4, it doesn't work, then you're said to have an empty set. Alright, and that's how you denote empty set. So the number that you got doesn't work. That's what that means. Alright, a few more. Let's say we have square root of 2t minus 4 equals t minus 2 square. So you end up with 2t minus 4. And over here is t minus 2 squared, so that's like saying t minus 2 times t minus 2. Alright, so equals first to first, which is t squared, outside, or outside, negative 2t, inside, negative 2t, last and last, plus 40. Alright, so 2t minus y on the square root sign, square it, equals t minus 2, we square it. Okay, and t minus 2 squared, and here let me write it like this, like it should be written. Okay, so the t minus 2 is squared. I want to show you that here. This is what we get. These are like terms. So 2t minus 4, 2t minus 4 equals t squared minus 4t plus 40. Alright, it's quadratic because of the 2, that's the highest degree, so you get all your terms together. So I'm going to subtract 2t and subtract 2t from here to get my t's together. I'm going to add 4 here and add 4 over here to get my constants together. So I end up with nothing on the left equals t squared minus 6t plus 44. Alright, so let's see here. Making sure I did. Wait a minute. What am I doing? 44. This is a doggone 4 right here. I don't know what I was doing putting that there and that there. So this right here changes 8, right? Alright, so first and first, t squared, outside negative 2t, inside negative 2t, last and last is plus 4. Combine the like terms in the middle, minus 4t, still got my 4. Subtract 2t, that's negative 6t. Add 4, that's an 8. Alright, now I'm back in the picture. Okay, so I have this. Alright, and now I can factor. Oops. And y'all bear with me. I'm fighting some sleep now. Alright. Looking at this screen too long. Starting to put me to sleep. So hang in there with me. Alright, we almost finished. So we got that. I want to get my 8. So that's a negative 4 and a negative 2. There we go. Alright, we got a negative 4 and a negative 2. Those will be my factors. So I find my first factor, t minus 4, set it equal to 0. Second factor, t minus 2, set it equal to 0. Plus 2 plus 2 plus 4 plus 4. T equals 4. T equals 2. Alright, so I have two solutions. T equals 4 and t equals 2, but I have to check them. Alright, we always check. for radical equations. It's got a radical in it, we want to check it. Alright, so I'll go back to the initial equation, and I'm going to use my 4 first. So I'm going to say square root of 2t, and t is 4, alright, minus 4 equals t is 4, minus 2. Alright, so that's 2 minus 4 is 8, 8 minus 4 is 4, square root of 4, which equals 4 minus 2, which is 2, square root of 4 is 2, 2 equals 2. Alright, so when I plugged in the 4, that works. Alright, this checks out. So when I plug in t equals 4, that's good. Okay, that checks. So now I want to check. Now I want to check when t equals 2. So I make my 2 square root of t. T is now 2. Square root of 2 times 2 minus 4 equals 2 minus 2. Alright, so 2t minus 4 equals t minus 2. That's my initial equation. Alright, plugging in 2 for t now. So there's my t and there's my t, from my 2 for t. So that's 4 minus 4, so that's square root of 0. Alright, equals 2 minus 2 is 0. Okay, so square root of 0 is 0, 0 equals 0. That checks out. So t equals 2 is good. So my solution is t equals 2 and t equals 4. Right there. Okay, 2 and 4. That works. Alright. Try some more. Alright, I got my second win, so we're rolling now. Here we go. We have this. Need to get y's together. Okay, so I say square root of y equals, and I would subtract 6 and subtract 6. Those will cancel, and I have y minus 6 over here. And I want to get rid of the square root, so I take the square. And I take the square. Notice I take the square of the whole side over here because of this. So the square and square root will cancel and just leave me y equals, and this right here will give me y squared, because this is like saying y minus 6 times y minus 6. Alright, so that's y squared minus 12y, alright, plus 36 is what you'd have now. It's quadratic, so you want to get all the terms quadratic, because I see that square there. My degree is 2, so I want to move this y over here with this y, and that leaves me a 0 over there. So I have y squared minus 13y plus 36. Alright, now I'm set to factor. So I have a y. My 36 is like saying a minus 9 and a minus 4. So first and first is first, last and last is last. Outside and inside gives me a negative 13. So when I set this factor equal to 0, I get y equals 9. When I set this factor equal to 0, I get y equals 4. So now I have a 9 and a 4, and if I'm going to check those, alright, so I'm going to plug into my initial problem. First, y is 9. Okay, so I'm going to say square root of 9 plus 6, alright, because I'm plugging in 9 for y, equals 9. Alright, so square root of 9 is 3, plus 6 equals 9. 3 plus 6 is 9. 9 equals 9. That is true. So y equals 9. That checks out. We're good. So now we're going to try this guy. Okay, now we're going to check that guy. Y equals 4. This. So now it's square root of y, which is 4, plus 6 equals y, which is 4. Square root of 4 is 2. 2 plus 6 equals 4. 2 plus 6 we know to be 8. Does 8 equal 4? No, it does not equal 4. 8 does not equal 4. So this does not check out. So y equals 4 is not a solution, and your only solution ends up being the 9. The 9 was the only one that worked. Alright, the 9 was your only solution that worked. Alright, so that should be enough. We've seen enough examples now to get a feel for how we would treat problems when trying to solve equations with radicals in them. The main thing again is to make sure you check your solutions to see that they do indeed work. Okay? Alright, at this time we will conclude this session.